One more set of examples on 11D. So we're on 109. This next example is different because the leading coefficient of the u squared is negative, and we don't want that. So we are going to rewrite this negative. We're going to pull this negative out. We're going to change this guy. This is like what we did before. And we are going to rewrite this as u plus 4 over u minus 4 minus 16u. The numerator doesn't change, but the signs in the denominator do change to positive u squared minus 16. So satisfy yourself that if you multiply negative 1 times this expression, you will end up back where we started at minus u squared plus 16. So this is legal. We can do this, and it's going to help us when we factor to not have to deal with this negative 1 coefficient. So now we want to factor first, factor first. So it's going to look like this. I hope you noticed that this guy is the difference of two squares. He is u plus 4, u minus 4. Once you notice, I'm not happy with this calligraphy pen. I'm switching. Once you notice that, then you notice the similarity in looking for our LCD. We have a u minus 4, and we have one over here. We only need to write it once, but we also need a u plus 4 as part of our common denominator. So u plus 4, u minus 4. Is going to be our common denominator. What do we need to multiply to get there from here? He's got the minus 4. We need to multiply the u plus 4. He's already got a u plus 4, but he needs another one. This guy, how do we get from here to here? Oh, we're already there. So we don't have to multiply this 16u times anything. Now we have to clean this up. So we do have a single fraction bar, which is good. U plus 4, u minus 4. I need to do this double distribution. And when I do that, I get u squared plus 8u plus 16. Am I doing this right? Okay, so I've got u squared plus 8u plus 16 for this numerator, and then I've got minus 16u on the back end. So I can continue to collect like terms, and I have u squared minus 8u plus 16 all over u plus 4, u minus 4. So you need to consider finding factors for this guy. And if you think of a simple factoring, 4 and 4 will add to 8 and multiply to 16. So this is going to be u minus 4 times u minus 4 all over our common denominator, u plus 4, u minus 4. You probably are seeing crazy u stars like me, but there's our answer right here. Okay, let's go see what this guy brings to the table. All right, so our first trinomial, factor first. So let's look at what this trinomial might. Do you need me, or are you just coming in? Just your bag? Okay. This trinomial, let's look at factoring this trinomial. And we can factor it into x minus 2, x plus 1. And this second fraction, we can take out the GCF, which is x. And now we have our factored form, and now we need to set up our LCD. Our LCD is going to have one of each of these pieces. So we need an x, we need an x plus 1, and we need an x minus 2. We don't have to write the x plus 1 twice, even though he's in both places. One will do. So our LCD is going to be 3 factors. And just like we did before, we've got to determine what we need to multiply by to get from here to here. He's got 2 of the pieces, he's missing the x, so I have to multiply the 3 times x. This one, he's got the x plus 1, but he does not have the x minus 2. So 1 times x minus 2 is going to be that new numerator. So I'm going to rewrite with a single fraction bar, and I am going to say 3x, and I'm going to distribute this negative 1 to each piece. So I'm going to say minus x plus 2. All right, I'm going over here, running out of room. So what do I have now? I have 2x plus 2 all over the common denominator. I'm just going to put CD, common denominator. And I'm going to factor out the GCF, which is 2. And my common denominator is x times x plus 1 times x minus 2. And we do have a term in the numerator and denominator that'll cancel. And we can put our answer back together as 2 over x times x minus 2. All right, we've got one more on this page. Oh, Lordy, it takes a lot of room. Okay, I better write small. So let's look at this one. We've got 2 trinomials, so obviously we're going to factor first. No GCF, but we can certainly factor into 2 binomials. And if you want to stop the video and go do this factoring, you can do it, but I've already done it, so I'm going to keep rolling here. And this guy factors to x minus 3, x plus 1. So the LCD is going to be x plus 3, x plus 1. He's got the x plus and x minus 3. So we've got 3 factors. Maybe we're not ready for the single fraction bar yet. Just wishing. But we could change colors. So let's write our GCF. Our shell of a fraction. This always works for me. Just do this a piece at a time. How do we get from here to here? What are we missing? We've got the x plus 3, we've got the x plus 1, but we don't have the x minus 3. So that's what you're going to multiply the existing numerator by. Don't forget the existing numerator. It's kind of easy to leave him out, because he's just hanging out waiting to be multiplied. So what does the 2 have to be multiplied by? I've got the x minus 3, the x plus 1. He needs the x plus 3. Now I'm ready for the single fraction bar. And I'm just going to put LCD until I get to the point where I'm ready to see what cancels. So distribute x squared minus 3x. I am going to distribute negative 2. So minus 2x minus 6. Clean it up. So I have x squared minus 5x minus 6 all over the LCD. Look for the factors, the 2 binomials that will factor, and it x minus 6, x plus 1 all over the LCD, which is, I'm going to write it now, x plus 3, x minus 3, x plus 1. So now we do have a factor in common, and we can rewrite our answer. You do not have to double distribute this this denominator, x plus 3, x minus 3. You can leave your answer like this. That is perfectly fine. Bye. See you on the other side.